Next up is the Rotameter, a classic example of a variable area flow meter. This device works on a very simple yet elegant principle. Picture a vertical tapered glass or plastic tube. Inside that tube is a small float, not connected to anything, that's free to move up or down depending on the fluid flow. As the fluid enters from the bottom, it pushes the float upwards. The float rises until the upward hydraulic force, caused by the flowing fluid, balances with the weight of the float minus the buoyancy force. At that point, the float becomes stable, and its height directly represents the flow rate. Now here's the clever part: the tube is tapered, meaning its internal diameter increases as you go up. This gives a variable annular area, the gap between the float and the tube wall, that changes with the float's position. Because of this taper, the float moves higher for higher flow, making the flow rate proportional to the float's height. Most rotameters come with a calibration scale printed on the tube, so you can read the flow rate directly without any calculation. The float's position reflects a balance of forces. Upward force from fluid pressure gravity, mass of float, buoyant force due to fluid density. This gives us a very stable, reliable, and visual flow indication, perfect for quick checks and low-cost installations.